Now, in this video, we're going to look at a quite challenging questions whereby we need to raise a complex number to the power of another complex number. So the first thing we're going to do is to let y is equal to this expression, which is 2 minus 2i, and everything to the power 2 plus 5i. I is the imaginary unit and is equal to the square root of -1. Good. Now let's take the ln of both sides. So the ln of y is equal to the ln of 2 minus 2i and 2 plus 5i. So the ln for all this. Now let's go here and review some of the ln properties. Ln to a to the power x can be written as x ln of a. So we're going to go here and apply it. We have a power here, yeah? So we bring it down. Ln y equal 2 plus 5i ln 2 minus 2i. The next step is to express this complex number 2 minus 2i in polar form. Now in polar form, a complex number is given by rho e to the power I theta. Okay, now let's go here and explain all this. Now my complex number 2 minus 2i in a diagram is as follows. So this is 2, the real part. This is -2, the imaginary part. And then this is my 2 minus 2i. Now the polar form, rho, the rho is equal to the square root of the real part, 2 square, plus the imaginary part. Now simplifying this, it will be square root of 4 plus 4, so 2 square root of 2. Now the angle theta, where is the angle theta? The angle theta is this. So the tangent of theta here is equal to the opposite side, which is this, which is -2 or -2, divided by the adjacent side. So this is theta, opposite side -2, adjacent side 2. That gives me -1. And theta is equal to arc tan of -1, which is -pi over 4. So let's go here. 2 minus 2i can be written as 2 square root of 2, which is the rho, e to the power minus I pi over 4. Now remember, we need the ln, the logarithm. So the ln of 2 minus 2i is also equal to the ln. We substitute here 2 minus 2i by this, so 2 square root of 2 e to the power minus I pi over 4. This is a pi here. Good. Now we have the ln of a product, and we know that ln of a multiplied by b will give ln of a plus ln of b. So we apply this here, and we say that the ln of 2 minus 2i is equal to ln of 2 square root of 2 plus ln e minus I to the power 4. Okay, good. Now this is the ln. Now we need another formula, another rule. Ln e to the power x is equal to x. So all this is going to simplify. So this is ln 2 square root of 2 minus I pi over 4. Okay, good. Now let's go to our expression, the ln y. So the ln y is equal to 2 plus 5i multiply. So I am here, I'm working here now, yeah? 2 plus 5i, and then this is this, which is this. So all this is equal to ln 2 square root 2 minus I pi over 4 square root of 2 here. Good. Now this here is just the product of a normal of two complex numbers, yeah. So we just go and multiply this by this. Yeah, when we multiply, we get this expression. We get all this expression here. Let's explain this. 2 by 2 ln 2, it's here. And then this part 5i multiplied by minus I pi over 4. Remember, I squared give me the minus 1 with the minus here. So all this becomes 5 pi over 4. And it's a real number. And now the imaginary part comes from 5 ln 2 square root 2. And then the other one is 2 multiply minus I pi over 4 simplified to this. Now, this is ln y. So y is equal to e to the power 2 ln 2 square root of 2 plus 5 pi over 4 plus I 5 ln 2 square root 2 minus pi over 2. So this is the y we are looking for. Now we have the form e to the power a plus b. That will give me ea multiply eb. So if you want, this is the small a and this is the b. So this is equal, y is equal to e to the power 2 ln 2 square root 2 plus this is 5 pi plus 5 pi over 4 and then multiplied by e to the power 5 ln 2 square root 2 minus pi over 2. Good. So we continue. This is a real number. Yeah? This is a real number multiplied by a complex number. So y is equal, let's call it a, yeah, capital A. So this is capital A. Now, what we have here, we have e to the power I theta. And this is by Euler formula, we can write it like this. So this is A, and then we multiply by cosine theta. This is our theta, yeah? Cosine 5 ln 2 square root of 2 minus pi over 2 plus I am here now, I the sine of theta. Theta again is 5 ln 2 square root 2 minus pi over 2. Now let's make some simplifications starting with a. Yeah? A is equal to this, e to the power 2 ln 2 square root 2 plus 5 pi over 2. So let's go here, e 2 ln 2 square root 2 is equal, now x ln y is equal to ln y to the power x. We are going to apply it here. So this is e to the power ln 2 square root of 2 power 2. Now this gives me e. Now this power 2, that gives me 8, and all this simplifies to 8. So this a will be 8 e to the power 5 pi over 2. That's for a. Now let's go here. This is cosine something minus pi over 2. So cosine something minus pi over 2, that gives me sine alpha. So cosine alpha minus pi over 2 equal to sine alpha. And here what we have sine alpha minus pi over 2, that gives you minus cosine alpha. Now let's go and apply them, all these simplifications here. So we start with a. A is 8 e 5 pi over 2, open the bracket. Now cosine alpha minus pi over 2, so that's going to give me sine of alpha is the expression 5 ln 2 square root of 2, and then plus there is a minus sign, so minus I cosine 5 ln 2 square root of 2 again. Here we close the bracket. So this is our complex number in standard form, or almost. We need to multiply now. So y is equal to 8 5 pi over 2 multiplied by the sine of 5 ln 2 square root of 2. This is the real part. And then minus I 8 5 pi e to the power 5 pi over 2, and then multiply by the cosine 5 ln 2 square root of 2. So this is the final expression for y. Now what we can do is take our calculator and make some approximations. So this is the approximation, real part and imaginary part rounded to the nearest unit.